space time. All right. Sorry about that. Yesterday I just could not barely move. Actually, I laid in bed most of the day and had ice on my back from hiking and camping over the weekend, the Labor Day weekend. So let's take a look at what we've got to do today. It did help me out a little bit. I did realize that some of you guys are using this right here. So when I say calendar, this is not the calendar I'm talking about. This will give you due dates and stuff like that, but that's not the calendar that tells you exactly what you should be doing each day. That calendar is under the modules, or it's the current calendar here. So if you need to get to that, you go to modules and then the week with the dates, 7th through the 10th. No school Labor Day. And then you'll see Tuesday, September 8th. It says to download that periodic table activity. Excuse me. Basically with this, you're going to color in a periodic table. So it seemed like some people actually turned that activity in, which is awesome. Don't forget, there also is the periodic table worksheet with that. So make sure you answer the questions with that as well. So let's take a look at what we got today. We want to discuss how the periodic table is set up, play the what element am I game, and work through the puzzle page. Now the puzzle page is set up as basically the same setup as Friday's quiz. So the periodic table, to test you over that, we'll have a quiz on Friday that's set up similar to the activity that you're going to be finishing up tonight. So without further ado, let's take a look at what it looks like to check out the periodic table of elements. To do that, I've got two things. I've got one, I've got a periodic table of elements. And two, I've got the last page of our note guide. So if you recall, our note guide dealing with Unit 5. The last page of it is the periodic table overview. I've also got set up here a periodic table of elements. Now you may have the colored version, which is awesome. Mine, unfortunately, I don't have a colored printer. So mine is going to be in scales of gray. So 75% of all the elements on the periodic table are metals. This corner up here and hydrogen over here, these are our non-metals. And then the metalloids or semi-metals. They have properties of both metals, for example, lustrous, malleable, which means they can be shaped, ductile, which means they can be drawn into wire, and conduct heat and electricity. Non-metals are kind of opposite of this. They're not lustrous, they're dull. The solid non-metals are brittle. Otherwise, they're gases, on both of them have a liquid, but they don't conduct electricity or heat. They're insulators. Metalloids have properties that are similar to both. The way we do the metalloids is basically we take a look at this little line we have here that's darkened. Then I suggest if you have like a highlighter or something like that, you can highlight these guys. If you don't, then you can use some other color or something like that, colored pencils or something like that. And basically, we're just going to get some type of marking here on the metalloids. There's some areas to sit there and say, well, this isn't a metalloid, but this is the most common one. Anything touching this line, except for aluminum and polonium, are metalloids. Aluminum, polonium have more characteristics to metals than they do to the metalloids. And I usually call them semi-metals instead of metalloids or metalloids. So that's those guys. When we're looking at the periodic table, we've got what we call periods, which go across this way. This is the first period, second period, third period, fourth period. And we got families or groups that go down this way. So this is group 1A, 2A. Then we got all these B elements. They are known as the transition metals. Then we've got group 3A, 4A, 5A, 6A, 7A, 8A. Group 1A is also called the alkali metals. Group 2A is called the alkaline earth metals. Again, all of these guys all the way over to polonium and stuff like that, the tin and bismuth, these are called the transition metals. They are transitioning into the semi-metals and eventually into the non-metals. Group 8A over here is known as the noble gases. Group 7A is called the halogens. And group 6A is called the chalcogens. But nobody calls it that. Everybody calls it the oxygen family. And this is the nitrogen family, the carbon family, the boron family. Families go up and down, periods go left to right. Down at the bottom, we have what we call the inner transition metals. This would be the lanthanide series. This would be the actinide series. When you're actually looking at that, imagine if we were to split the periodic table right here and shove those in there. You can see it goes from 56, then to 57, then to 88 to 89. So basically these two actually fit in between this part of the periodic table and this part. The reason why we do it this way, why we break it down and put it down there, is so that it'll fit on one page. So it'll fit on one page. And some of these elements are radioactivity, or have radioactivity and radioactive, and that starts right here at polonium. So if you can draw the radioactive symbol, that will tell you that polonium, you've probably seen it, usually there's a circle around it, but basically give you some idea that 84 and above are radioactive. So anything polonium and after are radioactive. If we take a look, uranium is the last natural forming element on Earth. Uranium is the last natural forming element on Earth. So that means neptunium, plutonium, americium, curium, berkelium, californium. These elements are man-made. We take uranium or other elements and we bombard them with alpha particles and stuff. Certain elements on here cannot exist as their self, so they are diatomic. They include hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. These are the diatomic gases, so when they are gases, they don't exist as just one H atom or one N atom. They have to be bonded to another one. Otherwise, they won't be in their elemental form. They'll form other compounds. They're too reactive otherwise. Now, as we said, group 1A is here. That A, that group A number, that tells us the number of valence electrons. or the outer energy level electrons. So if we take a look, if it's in group 1A, it has 1 valence electron. So when it forms an ion, instead of gaining 7, a lot of times it will lose 1. A hydrogen being a non-metal, it can either lose or gain 1. So we put a little plus minus 1 for hydrogen. Group 2A, that means it has 2 valence electrons. So it will lose 2 electrons, giving it a charge of plus 2. Remember, it's all about getting the same configuration as the noble gases. So if beryllium loses 2, 1, 2, it now has the same number of electrons as helium. Potassium will lose 1, giving it 18 electrons. The noble gases do not gain or lose any, but if you were in group 7A, you would gain 1. That would allow you to get that octet. Let me write that a little better. Write it a little bigger. Yeah. Now there we go. So minus 1, because we've gained 1 electron. Fluorine gains 1 electron to get 10. Remember, the 9 protons still identifies this as fluorine, but it has the stability of the electron configuration of neon. Oxygen, group 6A, to get to 8, we gain 2 electrons. 5A, to get to 8, we gain 3. Now there are a few elements that have set numbers that they gain or lose. Silver loses 1, zinc loses 2, and aluminum loses 3. So we'll just write those in. For these guys that we didn't get a number for, they vary how many electrons they lose. And we'll get to that another date. But just keep in mind that they all have 2 valence electrons if they're in group B. The transition metals here have 2 valence electrons, and their charges of their ions changes unless it has a number written by it. Last thing we can do is, if this is group 1A, we could also call this group 1. This group 2, group 3, group 4, group 5, group 6, group 7. We're going to subdivide these. This is group 8, 9, and 10. Group 11, group 12, group 13, 13, group 14, group 15, group 16, 17, and group 18. That's what we got. There's a nice periodic table with everything we need to have labeled for this, this unit and most of next. So from what I've told you, let's play what element am I? The faster we answer these, the quicker we can end the Zoom, and you guys can get to work on that puzzle page. So what element am I? I'll show you this whole screen. So all I did was click on what element am I? It's not showing the screen I want, I don't think. Let's try that again. Yeah, I guess it is working. So if we take a look, what element am I? I am the lightest gas. So remember, the gases are the dark ones, liquids are the less dark, and then the solids are the clear ones, or well, you can see through them, the white ones if you want. So we have all of these. Take a look at your gases and tell me which one is the lightest gas. You can type it in the chat or unmute and say it.
Hydrogen.
Who is the lightest gas?
Is it hydrogen?
A little louder.
Hydrogen?
It is hydrogen. Good. And Will's got it too. Hydrogen. This is a gas. It's 1.01. Keep in mind, it doesn't say the lightest noble gas or anything. It just says the lightest gas. So now we're looking for a gas again, but we're looking for one that is radioactive. You can type in the symbol for it, or you can type in the name, or you can unmute and say it. We're looking for the radioactive gas. There we go. RN, good. Radon. William, nice. This element has 3 more protons than sulfur. So we're using a little bit of, algebra here. 3 more protons than sulfur. So this element plus 3, X equals sulfur's number of protons plus 3. And who is that? 16 plus 3. Who's got that many protons?
Potassium?
Potassium is correct. 3 plus 16 is 19. When we look at the atomic number for potassium, we see 19. I am from group 14, period 5. I'm from group 14, period 5. Not lead.
10.
10. Don't forget, we have 1 period here, 2, 3, 4, 5. It might be best to look over at the period numbers over on the side, on the left side here. I have 6 valence electrons. I'm in the same period as potassium. I have 6 valence electrons and am in the same period as potassium. So 6 valence electrons. So that means you're going to need to know your Roman numerals. What is a Roman numeral 6?
VI?
Yep. VI is 6. So that means we are going to be looking here at VI. Remember, it's only the A's. So it's the same period as potassium. So we want to find potassium. Go over to VI. None other than selenium. Selenium. I am the smallest radioactive element. What did we say the first radioactive element was? You having trouble spelling? Is it autocorrecting for you? There we go. Polonium. There's nothing called punium. There is no punium, just polonium. Yeah. PO would have worked. Good. I have half as many protons as calcium. So you got to find calcium and its number of protons and divide it by 2. Neon. Nice, quick. 4 times my atomic number is 2 less than neon. 4 times my atomic number is 2 less than neon. So I'll give you a few seconds for that algebra. Oh, good, Will. Good. So let's show everybody else how to do that. So 4 times my atomic number is 2 less than neon. So 4x equals 10 minus 2. Well, I don't know if it is germanium now. Let's look at it again. 4 times my atomic number is 2 less than neon. I thought you had He. Because 10 minus 2 is 8. 4x equals 8. We divide both sides by 4. X equals 8 over 4. And x equals 2. So that would be helium. He. I am the smallest diatomic element. I am the smallest diatomic element. So remember our diatomic elements? Which of these is the smallest? Hydrogen is correct. Yeah, definitely the smallest. Even though there's 2 of them, it's still 2.02 versus nitrogen at 28.02. I am the first element on the periodic table with a smaller atomic mass than the element that comes before me. So we're looking at the atomic masses here. So see here how this goes from 55.85 to 58.93. Most of the time they go up. But here, 58.93 to 58.71, it goes down. This is not the first case that this happens. So I need you to find the element that happens to first. And the first first element on the periodic table with a smaller atomic mass than the element before me. Argon and potassium is correct. Nice job, Anthony. It's a hard one to see, but see here, argon is 39.95, potassium is 39.10. That's a hard one because they're on opposite sides of the periodic table, but this element is the one that comes before potassium. Back to the easy ones. I am from group 16, period 6. Group 16, period 6. Yeah, right. Polonium's all over the place on this. To do that, you have to look up here at the group 16, and you have to look down here at period 6. It's like some type of bingo thing, right? 16, period 6. I have 3 fewer protons than sulfur. I have 3 fewer protons than sulfur. Well, if you stop answering, Anthony, I'm afraid that we would be here until the bell rings. Unless somebody else is going to step up. There we go, aluminium. The way he got that is he found sulfur. 1, 2, 3 less than that. Aluminium. I am the heaviest gas. Who is the heaviest gas? OG. I am not sure what OG is on there, but it is radon. If we take a look, the darker ones, remember, are the gases, and radon is 222. The one before that would be 131. I have 3 electrons in my outer energy level, and I'm in period 4. So we're looking for 3 electrons in the outer energy level in period 4. So again, this is period 4, and the number of valence electrons is equal to the group A number. So we're looking for the Roman numeral for 4. So here is Roman numeral 4. Here is Roman numeral 4. So that, wait, let me make sure. I am 3 electrons in my outer energy shell. So we're not looking for Roman numeral 4. We're looking for Roman numeral 3. And I'm in period 4. That would be none other than gallium. Hardest one, I'll give 5 bonus points for this last one. Whoever gets it first, go ahead and type it in. You can write the symbol or the name. I have half the number of protons as barium-112 has neutrons. I have half the number of protons as barium-112 has neutrons. No. Set a timer for 20 seconds.
Okay, 20 seconds and counting.
Well, there's our 20 seconds. Cobalt, so close, William. So close. Let's break it down. It's barium-112. Barium-112 has 56 protons. So that means that we have 112 minus 56, 112 minus 56. Yeah, that's going to
The
be
answer is 56.
56. So we have 56. That's half the number, right? We need half of this number, and that's how many protons this element has. 56 divided by 2,
It's 28.
28 protons. So we're looking for an element with the atomic number 28. And that would be nickel. Yep. Good old nickel. All right, last thing for today. So the last thing for today is you'll want to get a copy of the puzzle page, which looks like this right here. And on the back of it, it has a periodic table. What do you call those? Crosswords. So again, it has these same type of things. I have 26 protons. I'm the head of the carbon family, known as the basis of life. All of these things are there. This is the harder part of this. So I'm going to switch it over to a printed out copy I have of it. That way I can write on it easier. But you obviously can write on the PDF version using your Chromebook. So basically we have the first 25 elements, but they've been given a code letter. So it says V is an inert gas. That's the same as saying that B is a noble gas. V is in the family of WNVG. And we know that the noble gases are over here. So that means that we have, this could be WNVG, 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 WNVG. Once we start filling some of these in, then that will limit the choices we can have for other ones. So if we take a look, E is an alkali metal. So EPFZ, they are the alkali metals. We take a look, these are the alkali metals right here. Now if we want, we can sit there and write, this is period 1, period 2, period 3, period 4. That makes it nice. If we want, we could even say, okay, this is 1A. That means it gets a +1 charge. This is 2A. That means it gets a +2 charge. And any of the stuff that we put on this periodic table, we can use for this periodic table. But we've got to figure these clues out. E is an alkali metal. So that tells me that the first elements in this period, or I'm sorry, in this family are E, P, F, and Z. But I don't know anything else about that. E, P, oh, here we go. F. F has only 1 proton in each atom. Well, what element has 1 proton in each atom? Is it this one, this one, this one, or this one? Which of these 4 elements have 1 proton in each atom? That's the clue. F has 1 proton in each atom. Yeah, hydrogen. So right there, we know this is F. Easy enough. So now, all we got to do is figure out Z, P, or E. But here E, it says E has an atomic number less than that of Z, but greater than that of P. So that means that we should be able to figure out where E goes here. 1, 2, 3. And if we find out where E goes, since E has an atomic number less than Z, but greater than P, we would be able to find out P and Z based on where we put E. It's only one place for each code letter to go. And this is very similar to the way the quiz on Friday is. So that is the Zoom for today. Keep in mind that this is what you should be working on. If you still don't have the periodic table activity done, that may help you work on this. Don't forget that the periodic table activity is due on Thursday, along with the not only the questions, but also the colored periodic table activity. And you can see the periodic puzzle page. That's basically our assignment for tomorrow. So tomorrow's Zoom, I will come in and answer any questions that you have, and then allow you time to work on both of these assignments to make sure you complete this. Friday, I will answer any questions in the Zoom, and then you will do a quiz worksheet over that same type of puzzle page thing. After completing that, you should work on the review. And then Monday, we'll go over the review, and Tuesday, we'll have our test over matter and atoms. Questions for the group? Well, all right then. That ends it for the meeting. Hope you enjoyed. If you want to stick around and ask a question, by all means, I'll stop the recording now so that you have a little bit of privacy on that.